Hello, everybody. Welcome back to Easy Learn. And today's topic is area of triangles, within which we're dealing with non-right angle triangles. And it's practice time today. If you haven't watched my area of triangles explanation video yet, pause right here, check the link in the description below, go understand the concept first, and then come back for solving. So today's question is the area of the triangle is 360 centimeters square. Find angle x. Now this is my triangle which has a base of 20 centimeter and it's broken down into the smaller triangle that is the base for that is 4 centimeter and this is the angle x degrees that we're looking for. Now, in order to find my x degrees, and since we're dealing with the area, I'm going to be looking at the two formulas. That is, area of a non-right angled triangle provided that the base and height are known is base times height, and area of a non-right angled triangle provided that an angle enclosed between two lengths is known. So the formula for that is half AB sine C. Now I have to try and figure out which formula can I use. Now if you look at the second one, that's half AB sine C. Now if I want to deal with this particular formula, I have my I have my B, either the A or the B, but I just have one of them. And the sine C is also missing. I have it as X. And in order to find my X, I would need this length and this length. And the area is already given. But I just have one of the lengths as my 20 centimeter. This one is missing, which means I cannot use half AB sine C. Now, what if I try to do this one, the base times the height? Can I do base times height? Yes, I can. There's this vertical height that I can find out using this formula, that is area equals BH, or base times height, considering the fact that I already have my area as 360 and my base is given to me as 20. So when I have my area, I have my base 20, my h is missing, so I could just write it like that. 360 equals 20h. Now if I take this 20 to the other side, this 20 is in multiplication with the h. When it goes to the other side, it turns into division. So I'm going to do 360 divided by 20 equals my h. So 360 divided by 20 is going to be 2 ones 2 and 2 eighteens 36. So that gives me as h equals 18 centimeter. Now this is my height, that is 18 centimeter. But again, as you can see, I am still very far away from finding my x degrees. I need to still work out something in order to find my x. So as you can see that this small length right here is given to me as 4 centimeter, which means that if this whole thing is 20, and if one part of it is 4, then this part right here is supposed to be 20 minus 4. The 20 minus 4 is going to give me this length. And this length, 20 minus 4, is equal to 16. So this length becomes 16 centimeter. Now I have some more information that is putting me closer to finding my x. I have a height that is 18 centimeter and I have a base that is 16 centimeter. Now, if you try and notice this specific thing, you can see that this is forming a right angle triangle, this part right here. So I have a 16 centimeter as my base, and there is this 90-degree mark here, and I have this vertical length as 18, and this is the angle that is missing. Now, if you try and recall the trigonometric identities, that is the trigonometric functions, what are trigonometric functions used for? They're used to find length or angle of a right angle triangle. Because I'm dealing with length and there's an angle, this x, that's missing, so I think I can pretty much use my trigonometric functions. And within that, I have this sine, cos, tan table that I can refer to. And for that, I also need that which one's my A, O, and H. So A is the adjacent, that is the length that is enclosed between the right angle and the other angle given. So that's supposed to be my A. And then O is the opposite, that is length opposite to the given angle, which means if this is my angle, the length opposite to that is supposed to be my opposite. And H is the diagonal length, or the one opposite to 90 degree. So diagonal is this one right here. This is my H. Now in this particular example, just to make it more neat, I'm going to be drawing it once more. So this is my 90, this is my x, this is my 16, and this is my 18. And in order to find this out, you can see that the 16 is the length enclosed between the 90 degree and the given angle. So this is my A, and the length that is right opposite to the given angle becomes my O. So when I have my O and my A, as you can see, that how we implement the sine cos tan. Sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. And because in this example I have my 16 as the adjacent and 18 as my opposite, you can refer to the table and see that opposite and adjacent are mentioned in tan. That is, I have the length enclosed between the 90 degree and the given angle, and the length that is opposite to the given angle. Therefore, I'm going to be dealing with tan theta equals opposite over adjacent. So if I write that down, I have tan theta equals opposite over adjacent. Now I'm going to replace my variables. In place of theta, I have x. In place of my opposite, I have 18. And in place of my adjacent, I have 16. Now this tan, when it goes to the other side, it turns into something like this: tan minus 1, 18 over 16. Now, tan minus 1 is basically known as tan inverse. Tan inverse is the same as tan minus 1. When tan goes to the other side, or perhaps sine, cos, anything goes to the other side, they turn into sine, cos, or tan minus 1. That is the inverse. Now, if you put that on your calculator, first thing, make sure your calculator is set on degrees. Secondly, you're going to click this I and V, that is inverse. Once you click that, you have sine minus 1, cos minus 1, tan minus 1, and I'm going to be selecting my tan minus 1. When you do that, it comes something like this: arc tan, and then you write 18 divided by 16, which gives you 48.366, or I could just round it up to x equals 48.4. So I have my angle now, or the x, that is 48.4 degrees. This is how you find out. Using the area that was 360, I found out the height first using the formula base times height. Once you have that, and then you have your base, you jump back to your trigonometric identities, and then you figure out the sine, cos, tan, which one is more appropriate according to the lengths available to you. You have your opposite, we have our adjacent, we put the tan, and then we take tan to the other side. So it's tan inverse, put that on your calculator, and you'll get 48.4. So it's all about solving consciously and trying to um, mix and match information from different branches of trigonometry to solve such questions. That's pretty much it. Hope you enjoyed the video. Hope you understood. If you have any questions, any confusions, drop them down in the comment section below. Thank you so much for watching Easy Learn. Do not forget to like, share, and subscribe. Take care of yourselves until next time.